Have you ever wondered if machines could think? This cogitation isn't just a product of our modern era. The concept of artificial intelligence, a term we're all familiar with today, has been a part of our collective imagination for centuries, long before it became a tangible scientific reality. From ancient myths of automated servants to today's self-driving cars and voice-activated assistants, the idea of machines mimicking human intelligence has always held a certain allure. As we stand on the precipice of an AI-driven era, it's time to take a look back at how it all began. The journey of AI as we know it started in the mid-20th century, a time of rapid technological advancement and the burgeoning of a new scientific discipline. The year 1956 marked a significant milestone with the Dartmouth Workshop, a gathering of intellectuals who sought to explore the potential of machines to mimic human intelligence. It was at this workshop that the term artificial intelligence was coined. The event brought together some of the brightest minds of the era, including the likes of John McCarthy, the man credited with the inception of this term, and Alan Turing, whose work in theoretical computation laid the foundations for modern computer science. Turing, in particular, is a name that resonates within the halls of AI history. His Turing test, proposed in 1950, still serves as a benchmark for machine intelligence. If a machine could convincingly impersonate a human in a text-based conversation, Turing argued, it could be considered intelligent. John McCarthy, on the other hand, was instrumental in developing the programming language LISP, a cornerstone in the field of AI research and development. His contributions have shaped the way we approach artificial intelligence, emphasizing logical reasoning as a pathway to creating intelligent machines. During this period, several groundbreaking projects emerged. The logic theorist, often referred to as the first artificial intelligence program, was developed by Alan Newell and Herbert A. Simon. This program demonstrated the ability to mimic human problem-solving skills, marking a significant leap forward in AI research. Then there was ELIZA, an early natural language processing computer program created at MIT's Artificial Intelligence Laboratory. ELIZA was capable of simulating conversation by recognizing and responding to textual inputs, offering a glimpse into the potential of AI and human-computer interaction. These early efforts in the 50s and 60s, though rudimentary by today's standards, laid the groundwork for what was to come in the world of AI. They sparked the flame of possibility, igniting a field of study that continues to push the boundaries of what machines can achieve. However, the road to AI was not always smooth. As we delve into the late 70s through the 90s, we encounter a frosty period in the history of AI, fittingly termed AI Winter. The promise of AI had been vast and the optimism infectious. However, the high hopes began to crumble as the reality of technological limitations, coupled with inflated expectations, became apparent. This was a time when AI's potential seemed to be stuck in a deep freeze. Funding, which once flowed freely, started to dwindle as disillusionment set in. Governments and investors alike grew skeptical, disappointed by the pace of progress and the wide chasm between the promise of AI and its actual capabilities. The limitations of technology at the time meant that AI could not deliver on the grand visions that had been foreseen. The hype had outrun reality, leading to a backlash that resulted in a significant reduction in funding and a general cooling of interest in AI research. However, like the proverbial phoenix rising from the ashes, AI began to thaw out from its winter in the 90s. The catalyst? Advancements in a field known as machine learning. Machine learning, a subset of AI, involves the development of algorithms that allow computers to learn from and make decisions or predictions based on data. The 90s saw an explosion of interest in machine learning, fueled by the increasing power of computers and the advent of the internet, which provided a vast amount of data for these algorithms to learn from. Machine learning started to show promise in practical applications, from speech recognition to recommendation systems, reigniting interest and investment in AI. The revival was not immediate, and the scars of the AI winter were deep. Yet the progress made in this period was crucial. It laid the groundwork for the AI technologies we see today, from virtual assistants to self-driving cars. Despite the setbacks, AI continued to evolve, paving the way for the developments we see today. The dawn of the 21st century heralded a new era for AI. As we catapulted into the 2000s, the realm of artificial intelligence began to unfold like never before. A series of breakthroughs marked this period, demonstrating the potential of AI to not just mimic human intelligence, but to exceed it in remarkable ways. Perhaps the most emblematic instance was when IBM's Deep Blue, in the late 90s, stunned the world by defeating the reigning world chess champion, Garry Kasparov. This was a defining moment that set the stage for the 2000s, showing us that a machine could outwit a human in one of the most intellectually demanding games. Moving forward, IBM continued to push boundaries with Watson, a cognitive computing system. In 2011, Watson outperformed human contestants on the quiz show Jeopardy, again highlighting the ability of AI to understand and respond to complex human language. Meanwhile, Google's DeepMind was making waves with AlphaGo. This AI system, designed to play the ancient board game Go, made headlines in 2016 when it triumphed over world champion Lee Sedol. This was a monumental achievement, as Go is considered far more complex than chess, with a seemingly infinite number of possible moves. Parallel to these developments, the concept of autonomous vehicles started to gain traction. Companies like Tesla and Waymo were at the forefront, using AI to navigate complex traffic scenarios and make split-second decisions, demonstrating the incredible potential for AI in real-world applications. Furthermore, advancements in natural language processing, or NLP, have been transformative. AI can now understand, interpret, and generate human language with astonishing accuracy, powering the voice assistants we rely on, like Siri and Alexa. These advancements have brought us to the cusp of a new era, where AI is becoming an integral part of our daily lives. As we march into the future, AI continues to blur the lines between science fiction and reality, shaping a world where machines can learn, think, and even dream, just like us. But what does the future hold for AI? As we gaze into the hazy horizon of tomorrow, we see the vast potential of artificial intelligence unfolding before us. In a world where change is the only constant, AI is poised to become a transformative force in myriad realms. Take healthcare, for instance. AI could revolutionize this sector, making predictive diagnoses a reality and potentially saving countless lives. Imagine a world where diseases could be detected even before their symptoms manifest. By analyzing patterns and anomalies in health data, AI could alert us to potential health risks, enabling early intervention and prevention. In the education sector, AI could personalize learning like never before. Each student has unique learning styles and pace. Harnessing the power of AI, we could tailor education to each learner, fostering an environment where everyone can thrive. AI could also automate administrative tasks, giving educators more time to focus on what truly matters, teaching and nurturing minds. As for climate change, one of the most pressing issues of our time, AI could play a pivotal role in combating this global menace. By simulating and predicting climate patterns, AI could assist in creating more effective climate change mitigation strategies. It could also aid in the development of green technologies, accelerating our progress towards a sustainable future. However, with great power comes great responsibility. As AI continues to advance, ethical considerations cannot be overlooked. Issues such as data privacy, algorithmic bias, and the potential for job displacement are real and pressing. It's crucial that as we develop AI, we also cultivate an ethical framework to guide its use. Challenges aside, the future of AI is undeniably exciting. Its potential to revolutionize our world is immense. But it's not just about creating smarter machines. It's about enhancing human capability and ultimately improving the quality of life for all. As we continue to push the boundaries of AI, it's clear that this incredible journey is only just beginning. So we've taken a whirlwind tour through the history of AI. We embarked on a journey that began in the mid-20th century, when the seeds of this disruptive technology were first sown. We saw the birth of the term artificial intelligence in the 50s and 60s, and how it was nurtured by the pioneers of the field, who dared to dream of machines that could think. We then moved on to the late 70s and 90s, a period marked by the AI winter, a time of reduced funding and interest. Yet it was also a time of important advancements, of learning systems and expert systems, which laid the groundwork for the AI renaissance that was to come. As we entered the new millennium, we witnessed an explosion of AI applications, from data mining to autonomous vehicles, We saw how AI began to permeate every aspect of our lives, from the way we work to the way we play. We also looked ahead to the future of AI, a future full of promise and potential. We pondered upon the possibilities of superintelligent AI, of machines that could surpass human intelligence, and the ethical implications that come with it. AI has come a long way, and its story is far from over. As we look to the future, one can't help but wonder, what's next?